So good morning to one and all. This is Dr. K. Pushpa Rani, Associate Professor, Department of Computer Science and Engineering, MLR Institute of Technology. So coming to the overview of this video is recurrence relations. That is a third method called Master's theorem. There are two variations in the Master's theorem. So first variation is comparison of A value and B power D value. And coming to the second variation of Master's theorem, we are going to discuss in this video. So in the case of second variation of Master's theorem, the recurrence relation of the form is T of n equal to AT n by B plus theta of n to the power of k log to the power of p and n. This is the form of recurrence relation. In this second variation also, there are three cases are there. Depends upon the value of a and b power k, whether it is equal or greater than or it is less than. So depends upon the value of a and b power k, we need to find the time complexity of the recurrence relation. So not only that, based on the p value also we need to do the classification whether it belongs to case 1, case 2 or it is a case 3. Suppose if it is a greater than b power k, then the time complexity is T of n equal to theta of n to the power of log a base b. That is the time complexity. Second one is case 2, if a equal to b power k. If greater than, no need to verify the p value, whether it is a -1 or equal to -1 or greater than -1. If it is a equal condition is satisfied, again we need to check whether it is a p less than -1, then T of n equal to theta of n to the power of log a base p. If p equal to -1, then T of n equal to theta of n to the power of log a base b log n is the time complexity. If p value is greater than -1, then T of n equal to theta of log a base b log to the power of p plus 1 into n is the time complexity. Then coming to the case 3, so a less than b power k. Then what is the time complexity? Again there are two cases are there, whether the p value is less than 0, p value is greater than or equal to 0. T of n equal to theta of n to the power of k if p is less than 0 means negative value. If p value is greater than or equal to 0 means that is equal or greater than. Then the time complexity is theta of n to the power of k log to the power of p into n is the time complexity. Let us discuss some examples based on the second variation of Master's theorem. So consider T of n equal to AT, that is 2t n by 2 plus n log n. Whatever the recurrence relation that has given, converted into the recurrence relation of the form T of n equal to AT n by b plus theta of n to the power of k log p base n. Converting that equation, T of n equal to AT n by b plus theta of n to the power of k log to the power of p into n. This is the time complexity. Theta n to the power of log to the power of p into n, log to the power of p into n. So this is the given recurrence relation. From this equation, we need to find out whether what is the value of a equal to 2, b equal to 2, k is, so there is no power for n, so by default it is 1. There is no power for log, so it is also p equal to 1. So log to the power of 1 means 1 only. Now we need to observe whether it is a case 1, case 2, case 3. First check case 1. What is case 1? A greater than b power k. Case 1 is a greater than b power k. First check a greater than b power k. Condition is satisfied or not. A equal to 2. 2 greater than, b value is 2, k value is 1. 2 greater than 2. Condition false. So if the condition is false, go to case 2. A equal to b power k. Means a value is 2 equal to b power k. B value is 1 to k value is 1, 2 power 1. That is 2 equal to 2, condition true. If in the case of case 2, again there are 3 cases, whether p value is greater than 2, p value is, that is say p is less than minus 1, greater than minus 1, equal to minus 1. So what is p? P equal to 1. If p equal to 1, we need to check p less than minus 1 or equal to 1 or p greater than minus 1. Case 3 is satisfied because 1 greater than minus 1 condition is true. 1 is greater than minus 1. Then what is the t of n, time complex theta of n to the power of log a base b log p plus 1 into n. The time complexity, that is say under case 3, that case is 1 greater than minus 1 condition is true. Then the time complexity t of n equal to theta of n to the power of log a base b into log to the power of p plus 1 into n. That is equal to theta of n to the power of log a. A is to log a base 2, log to the power of p value is 1, log 2 into 2. That is equal to theta of log 2 base 2 is 1, n to the power of 1 log square into n. That is theta of n log square n is the time complexity for the recurrence relation. So what is the time complexity? T of n equal to theta of n to the power of log 2, then into n is the time complexity for the given recurrence relation. So the objective is we need to check whether it is say belongs to case 1 or case 2 or case 3. Based on the case 1, case 2, case 3, we are going to find the time complexity. Let us discuss one more example for the Master's theorem. So T of n equal to root 2 T of n by 2 plus log n. So substitute the corresponding recurrence relation according to the equation of recurrence relation. T of n equal to at n by 2 plus, what is the recurrence relation? T of n by 2, theta of n to the power of k, theta of n to the power of k log p to the power of n. So what is A? A equal to root 2. What is the value of root 2? 1.142. So then what is B? B equal to n. What is K? Nothing has the K equal to 0. What is P? P equal to 1. Here K value is not given. So we need to find out whether it is case 1, case 2, case 3. Case 1, A greater than B power K. So what is case 1? According to the formula, A greater than B power K. Now we need to check what is A value. A value is 1.142 greater than B power 0. 2 power 0 means 1. 1.142 greater than 1. Condition true. 2 power 0 is 1. So then the time complexity T of n equal to theta of n to the power of, what is the condition for, if it is a case 1 is satisfied, theta of log a base b n to the power of log a base b. That is theta of n to the power of log a means root 2 base b will get to theta of root n is the time complexity of the given recurrence relation. The time complexity T of n equal to theta of root n. So 2 will get cancelled, we get root n is the time complexity for the given recurrence relation. Coming to the third example. So T of n equal to at n by b plus theta of n to the power of k log to the power of p into n. There is no powers, then a value equal to 3, b equal to 2. That means n by 2. So n by 2 means k equal to 1 by 2. K equal to 1 by 2. There is no p value, p equal to 0. Then check case 1. Case 1 is a greater than b power k. What is a value? A value is 3 greater than k value b power 2 power 1 by 2. That means 3 greater than root 2. That is equal to 3 greater than 1.142. So condition true. 3 greater than 1 by 2. Condition true. Then apply case 1. T of n equal to theta of n to the power of log a base b. That is equal to n to the power of n log a is 3 base 2. So log 3 base 2, that is a to, according to the case 1, a to the power of k n to the power of log a, because a value is greater than 3 is greater than 1.42, then we'll get a to the power of log 3 base 2. So that is theta of n to the power of log 3 means we are going to get log 2 is 1.142, we'll get so some 2.142, then we'll get theta of n to the power of some 1.3 like that. Okay, that is the time complexity of the recurrence relation. We are going to get, so find out the exact value, then find out the time complexity of the recurrence relation. T of n equal to n to the power of 1.3 something, that is the exact time, approximate time complexity for the recurrence relation. So up to now what we have discussed, that is the recurrence relation. There are three methods to find the time complexity of the recurrence relation. One is that is a substitution method. In this substitution, there are two classifications are there. One is a forward substitution. Another one is a backward substitution. In forward substitution, we have to start from the base case to general case. Then in the case of backward substitution, start from the general case and you have to proceed until the base case is satisfied. In second method, that is a recursion tree method, we have to follow the strategy of divide and conquer strategy. Divide the main problem into sub-problem and each sub-problem can be solved independently. Third method is a master's theorem. In case of master's theorem, there are two variations are there. So that is a first variation depends upon the a value and b power d value. Second variation, a value and b power k along with the constant p also. Based on the p value also, we need to decide whether it belongs to case 1, case 2, case 3. So all these methods are used for finding the time complexity of the recurrence relation. Thank you.